when there is only one single velocity possessed by the particle. Second one, when there are more than one velocity components, provided all of them are constants, then also particle can follow the straight line motion. And after that, even if the acceleration appears apart from the velocity, then also particle can follow the straight line motion, subject to the condition if velocity and acceleration both appears along the same straight line. That means either both of them are appearing at 0° angle or they are appearing at 180° angle. We name the first law. First law is, yes, law of inertia, correct. And it is known as law of inertia, right. So first law is about law of inertia. And what you have said about the law of inertia, that is correct. There are two different states about which it is discussed. First is about the state of rest, that is the static inertia. Second is about the state of motion, that is known to be the kinetic inertial state. Is that okay? So either the state of rest, that is the static inertia, or the state of motion, that is kinetic inertia, is discussed in this law. So that means law of inertia is about two states, that is static inertia. So according to static inertia, a body maintains its state of rest. It maintains its state of rest. Are you getting me? A body maintains its state of rest, and in this state a body cannot change its state of rest unless and until any external force is applied on it, right. And that means a body maintains the state of rest means velocity is 0. Not only that, it is the momentum, linear momentum. Momentum is what? Mass into velocity, that is 0. Why I am using the term momentum, you will come to know after few minutes. Why I am writing or why I am emphasizing on the term momentum, to explain the state of static inertia of the body. Second is about the kinetic inertia. Second is about kinetic inertia. So in kinetic inertia, a body maintains its state of motion. A body maintains its state of motion with uniform velocity. So in this particular inertial characteristics, it is said that the body maintains its uniform velocity motion. So this implies that velocity of the body remains constant here. Not only that, it is the momentum It is the momentum, that is mass into velocity, is maintained constant. Are you getting me? So whenever we talk about the static inertia, it is about the zero state of rest, that means the zero velocity or zero momentum value state. And whenever we talk about the kinetic inertia, that means in this a body maintains its motion with uniform velocity. So uniform velocity means velocity remains constant, and when velocity is said to be remaining constant means momentum is constant. So it is about the term of momentum, that means in first law it is the term of momentum about which it has been said clearly that either the momentum will be zero or momentum will remain constant, right. So when body will have its momentum zero, that means body will be in a state of rest, so it will remain unmoved. And whenever a body will moving with the constant momentum means velocity constant, so this implies that motion will be along straight line. So with these two statement, we reach to one concluding idea. We can reach to one conclusion that, what is that conclusion? The conclusion is about the fundamental state of motion. I asked earlier also while explaining the topic of kinematics, that is motion in straight line or motion in a curved path. I said that straight line motion is that particular motion which can be explained by the basic equations of kinematics, that is V equal to U plus AT, S is equal to UT plus half AT square, and V square equal to U square plus 2AS, isn't it? By the use of these equations we can explain the straight line motion. We cannot explain any curved path motion by the use of these equations. Yes, we can apply these equations even to relate the velocities, to know the displacement, even in the parabolic path, but we used to do it in two different coordinate axes. We cannot apply this formula along the path of the curve on 2D, right. So that's why it is important to understand about the reflection of the statement, that when it is said that in kinetic inertia momentum will remain constant, that means motion will be along straight line. So finally, so that means we can reach to one conclusion that straight line motion is the fundamental state of kinematics. And while discussing the kinematics, that is straight line motion and parabolic motion, I have explained the basic characteristics because of which a particle can follow the straight line. What are the fundamental reasoning? I said for a particle to follow the straight line motion. Do you remember it or not? Reasons are the basic concepts, the basic conditions in which a particle can follow the straight line motion. The first of it is when there is only one single velocity possessed by the particle. Second one, when there are more than one velocity components, provided all of them are constants, then also particle can follow the straight line motion. And after that, even if the acceleration appears apart from the velocity, then also particle can follow the straight line motion, subject to the condition if velocity and acceleration both appears along the same straight line. That means either both of them are appearing at 0° angle or they are appearing at 180° angle.